Welcome back to the Deep Dive. It is January 18th, 2026. If you're listening to this, congratulations on navigating the first few weeks of the new year. We are firmly settled into the mid-2020s, and the tech landscape, it looks pretty different than it did just a few years ago. But today, we're looking at a language that has kind of refused to age gracefully. In fact, it's refused to age at all.
Yeah.
We are turning our attention to the ecosystem that, well, basically runs the world. Java.
Yeah, great to be here. And honestly, refusing to age is the perfect way to put it. If you look at the narratives from, say, 10 or 15 years ago, Java was supposed to be the new COBOL by now. It should be dead, or at least, stuck maintaining some dusty old banking servers while everyone moved on to Rust or Go.
Instead, we're looking at this roadmap for 2026 that reads like a high-performance computing manifesto. I mean, we're talking about running code directly on GPUs, restructuring memory layouts, training startup caches. This is not maintenance mode. This is a full-blown reinvention.
It really is. And we're basing today's deep dive on a really comprehensive breakdown of Oracle's development plans for this year. This comes from a great report by InfoWorld, analyzing a presentation by Nikolai Parlog. He's a developer advocate at Oracle, and he laid out the trajectory for what we're calling the Big Five projects.
The Big Five: Leyden, Loom, Valhalla, Panama, and Babylon. It sounds like a lineup for a spy thriller, doesn't it? The Babylon Protocol.
It does have that ring to it, but these are the code names for the OpenJDK initiatives that are, they're fundamentally rewriting the DNA of the Java platform. Our mission today is to unpack these five pillars, to really understand how they're making Java faster, lighter, and, this is the surprising part, a serious contender in the AI and hardware space.
Right, but before we get too excited, we need to apply a little 2026 realism, don't we?
Yeah.
The source material had a pretty big caveat that I think is important to frame this whole conversation.
Yes, and this is crucial for any developers listening who might be getting ready to, use all of this tomorrow. Nikolai Parlog was very clear. Just because the OpenJDK teams are working on these features in 2026, it does not guarantee they will all be released as finished products this year. This is a roadmap. It's a statement of intent, not a shopping list.
So nobody should go updating their production pipelines expecting magical native GPU support to just appear.
Exactly. But looking at what they're focusing on tells us exactly where the industry pressures are pushing Java. And the first pressure point is obvious: patience. Or, well, the lack of it.
Which brings us to Project Leyden. The source calls this the quest for instant speed.
Speed is the headline, yeah, but specifically it's about startup speed, the warm-up time.
The classic Java gripe. I think anyone who's worked with a JVM knows this. You start the app and then you just wait. It has to warm up. It's like an old diesel engine. You can't just floor it immediately.
That's a great analogy, but let's dig into why that happens, because it's actually a feature, not a bug usually. The JVM is incredibly smart. It uses JIT, or just-in-time compilation. It watches your code run. It identifies the hot spots that get used the most. And then it compiles those specific bits into super fast native machine code while the app is running.
Right, which creates amazing peak performance eventually. Once a Java app is warm, it flies. But that analysis takes time. It takes CPU cycles right when you're trying to launch. And in 2026, where we're spinning up thousands of serverless functions that might only live for a few seconds, that warm-up time is a killer. You can't spend 2 seconds warming up for a task that takes half a second.
Precisely. In a serverless world, startup time is money, literally. You are billed by the millisecond. So Project Leyden in 2026 is focusing heavily on AOT ahead-of-time compilation. The goal is to shift that heavy lifting from runtime to build time.
But AOT isn't brand new, is it? We've seen things like GraalVM doing native image compilation for a while. What's different here?
The nuance is how they're doing it within the standard hotspot JVM, without losing that dynamic nature of Java. According to the source, Leyden's working on a mechanism to create a code cache from a previous run of the application and make it instantly available when the JVM starts up again.
Wait, so it's like giving the JVM a memory. It remembers what happened last time.
In a way, yeah. Think of it like this. You hire a new employee. The first day, they're slow because they're learning the ropes. That's the JIT warm-up. Leyden essentially says, let's record everything that employee learned on day one, write it down, and hand it to the next employee. That new person hits the ground running.
That is incredibly efficient. And the source mentioned code cache portability. Does that mean I can ship that training manual with my app?
That is the holy grail they're exploring this year. You could have a build pipeline that runs your app, generates this optimized training data, the code cache, and then you deploy your application with that cache.
So my application starts up in production already knowing how to be fast.
Exactly, and they're also working on inspectability, so it's not a black box. Developers need to be able to look under the hood and see what the JVM has learned. It turns startup from a mystery into a tunable metric.
Okay, that's a massive quality of life improvement. But while Leyden handles how we start, we also need to talk about how we do a million things at once. Let's move to Project Loom.
The darling of the Java world for the last few years.
It really has been. Loom is all about concurrency. But for anyone listening who maybe hasn't looked at threading lately, what was the problem Loom was trying to solve?
The problem was resource exhaustion. Historically, a Java thread was just a wrapper around an operating system thread. And OS threads are heavy. They take up a lot of RAM megabytes per thread, and switching between them is slow. If you tried to spin up a million of them to handle a million connections, your server would just fall over.
So one thread per user was impossible at scale, and Loom introduced virtual threads to fix that.
Right. Virtual threads are lightweight. They're managed by the Java runtime, not the OS. You can have millions of them in the same memory space that used to hold just a few thousand OS threads. It decouples your code's concurrency from the hardware.
But virtual threads have been out for a bit. What's the big news for 2026?
We have a date. JDK 26, the version of Java due out this year, is in its ramp-down phase. It's scheduled for production release on March 17th, 2026.
Mark your calendars, March 17th.
And with JDK 26, the spotlight is on the structured concurrency API. It's going to be in preview with some small changes in this release.
Structured concurrency. It sounds very organized, but I feel like concurrency and structure are usually opposites. Threading usually feels like chaos. You launch a thread and hope to the best.
That is exactly what they're trying to fix. Think about normal code. You open a block of code, you know everything inside that block happens within that scope. It's structured.
Right, it's predictable.
But if you launched a new thread inside that block, it would just run off on its own. It could outlive the method that created it. It could fail silently. It was like launching a rocket and losing radio contact. Structured concurrency forces that thread to stay within the structure.
So it treats a group of related tasks, even in different threads, as a single unit of work.
Exactly. If one fails, the structure knows how to handle the others. It simplifies error handling and cancellation massively. It prevents what we call thread leaks.
So it stops your code from looking like a bowl of spaghetti when you're doing 10 parallel network calls.
Correct. And the feeling from Parlog's presentation is that this API is likely to be finalized by the end of 2026. So we're moving from a cool experimental feature to the standard way of writing Java.
That is a huge shift. It basically kills the need for complex reactive frameworks for, 90% of use cases. You just write simple blocking code that looks synchronous, but scales like it's async.
That's the Loom promise. Code like it's 1999, scale like it's 2026.
I love that. Okay, let's get to the one that breaks my brain a little bit. Project Valhalla. The source calls this redefining data.
This is arguably the deepest change. If Leyden is how we start and Loom is how we run, Valhalla is about how we store data in memory.
The source talks about value objects, and they gave a very specific definition. Class instances that have only final fields and lack object identity.
Lack object identity. That is the phrase that matters.
Let's unpack that. In Java, everything is an object. If I create 2 point objects, point A and point B, both with coordinates, a 1 and a 1A, to me, they're the same data. But to the JVM, they're different, right?
Correct. They live at different memory addresses. The JVM puts a header on each of them. This header lets you lock the object or distinguish this specific instance from that one. That is identity.
It's like having 2 identical $5 bills. They're worth the same, but they have different serial numbers.
Perfect analogy. Valhalla asks, do we always need the serial number? If I'm just calculating coordinates, I don't care which specific $5 bill you give me. I just care that it's worth $5.
So a value object is the $5 bill without the serial number.
Yes. It is defined solely by its data. If 2 value objects have the same fields, they are the same thing.
Why does the JVM team care so much about this? Is it just philosophical?
Oh, the payoff is massive.
Yeah.
It is purely performance and memory density. Identity is expensive. Those object headers take up memory. But worse than the size is the indirection.
The pointer chasing.
Exactly. In traditional Java, an array of objects is really an array of pointers to other places in memory. To read the data, the CPU has to jump all over RAM, which causes cache misses. Value objects, because they don't have identity, can be flattened. They can be stored right next to each other, just like primitive int types.
So you get the nice programming model of objects methods, encapsulation, but with the raw performance of primitives.
That's the goal, unification. bringing high-level code closer to the low-level hardware.
And what's the timeline? We've been hearing about Valhalla for a long time. It feels like the fusion energy of Java, always just a few years away.
It's been a long road, but the 2026 roadmap is concrete. They're working to deliver a preview of these value types in the second half of this year. They're also working on null-restricted types, so you can have an object that you know can never be null.
That alone would save a billion null pointer exceptions.
It would. It allows developers to opt in to a programming model that's safer and much, much faster for data-heavy apps.
Speaking of data heavy, let's talk about connecting Java to the outside world. Project Panama and Project Babylon.
These two go hand in hand. Valhalla fixes the inside of the house. Panama and Babylon open the doors to the rest of the neighborhood.
Okay, let's start with Panama. The report mentions the Vector API. And I have the chuckle here. The source notes it's getting its 11th incubation in JDK 26.
And you know, the 11th incubation, it's a bit of a meme, but it actually highlights how difficult and critical this is.
So for the listener, what is the Vector API? We're not talking about the old collection class of the 90s, are we?
Definitely not, no. This is about SIMD single instruction, multiple data. Modern CPUs can do math on huge chunks of numbers at once. Instead of adding 2 numbers, you can add 64 number to another 64 numbers in a single CPU cycle.
But Java hasn't really been able to access those instructions directly.
Not easily. The JVM tries to guess when it can use them, but the Vector API gives the developer a way to explicitly write code that compiles down to those super fast instructions. It's essential for things like cryptography and scientific computing. They need to get it right.
And Panama is also about talking to C code.
Yes. The Foreign Function in Memory API. It's the replacement for JNI, the Java native interface. If you've ever written JNI code, you know it was brittle, dangerous, and just a huge pain.
It was a nightmare. You'd write 10 lines of Java and 50 lines of C just to call one function.
FFM, combined with a tool called Jextract, lets Java talk to native libraries almost as easily as calling another Java method. In 2026, they're just refining it to make it even smoother.
So Panama builds the bridge to C. But Project Babylon? That feels like it's building a bridge to another planet.
Babylon is the new frontier. The goal is extending Java to foreign programming models. And they don't just mean C++A, they mean SQL and, crucially, the GPU.
This is the part that really caught my eye. The source talks about code reflection. How is that different from normal reflection?
Normal reflection lets you look at a class and ask, what methods do you have? It looks at the structure. Code reflection allows a framework to look at the actual code inside a method, specifically a lambda, and analyze the logic itself.
Why would you want to do that?
So you can translate it. Imagine you write a lambda in Java that does some heavy math. A framework could use code reflection to look at that Java code, understand it, and then automatically translate it into CODA code to run on a graphics card.
That is wild. So the developer writes Java, but the execution happens on an NVIDIA GPU.
Exactly. The Babylon team is actively working on proofs of concept to do exactly that for machine learning models.
This feels like a direct shot at Python. Python won the AI war because it's so good at gluing C++ and CA libraries together.
Right. Python is the glue language. Babylon is trying to make Java a better glue. If they pull this off, it positions Java as a legitimate high-performance language for the AI era. You wouldn't need to jump out to Python, just access the GPU.
It challenges that whole idea that Java is just middleware.
It is a survival strategy. To stay relevant in 2026, you have to play nice with GPUs. Babylon is Java's answer.
Okay, so we have instant startup, structured threading, flat memory, and GPU access. Let's finish up with the things that make our daily typing life better. Project Amber.
Project Amber. This is the quality of life project. It's not about changing the architecture. It's about reducing boilerplate.
What's on the menu for 2026?
String templates are a big one.
Finally, we've been concatenating strings with plus signs since 1995.
Or using string.format, which is clunky. String templates let you embed variables right into text in a safe, readable way. Java is finally catching up, but they're doing it with a big focus on security, specifically to prevent things like SQL injection.
That is a very Java approach, late to the party, but with a safety helmet. What else?
They're filing JEP's enhancement proposals for constant patterns and better pattern matching.
Pattern matching has been a theme for a while. It's really changing how we write if-else and switch statements, isn't it?
It is. It's shifting Java toward what they call data-oriented programming. You model your data openly and then use pattern matching to switch over the structure. It makes code so much cleaner.
Yeah, the source mentioned record-esque classes.
Yeah, this is interesting. Records were a huge hit because they're so concise. Record-esque suggests classes that have that brevity but maybe with different constraints. Maybe they can be mutable or have inheritance. It's about letting the developer express intent without writing 50 lines of getters and setters.
Letting the developer express intent. I feel like that sums up the whole 2026 roadmap. It's removing the friction, whether that's startup time, thread management, or just verbose syntax.
Yeah, it really is.
So let's synthesize this. We are in January 2026. JDK 26 drops on March 17th. We have Valhalla previews coming later this year. What's the big picture?
Well, 2026 is a year of convergence. We're seeing Project Loom maturing concurrency is becoming structured and standard. We're seeing Leyden move from theory to implementation with AOT, and we're seeing Valhalla finally getting ready for a preview.
And we have Babylon pushing out to the GPU.
It is a very aggressive roadmap. It tells me that Oracle and the OpenJDK community are not content. They are actively re-architecting Java to solve modern problems: memory density, startup latency, and hardware acceleration.
It really dismantles that narrative that Java is just for old banking software.
Absolutely. When you combine instant startup from Leyden, massive concurrency from Loom, efficient memory from Valhalla, and GPU access from Babylon, you're building a language for the next decade of computing, not the last one.
It's exciting stuff. So here's the thought I want to leave you with today. We often talk about the AI wars between Python and C++. Python is the friendly interface, C++ is the muscle. But looking at this roadmap,
I think I know where you're going with this.
with Project Babylon pushing Java toward GPUs and Leyden making it start instantly, is Java trying to enter that ring? Is it trying to shed its reputation as heavy enterprise middleware to become a true systems language again?
If they pull off Valhalla and Babylon, I think the answer is yes. Java is tired of being the middleman. It wants to be the machine.
A bold move. We'll see how much of it lands in 2026. Thank you for diving deep with us today. Keep an eye out for that March 17th release, and we will catch you on the next one.
Goodbye, everyone.